La la la. All right. I will begin with a word of prayer. Eventually. Here we go. Dear Heavenly Father, we thank you for this day. I thank you for these students. Just ask that you bless our work today. Help us to understand what went wrong on the quiz, and just help us to make adjustments so we can do better on the test Friday. And we just thank you again for your many blessings, Lord Jesus. In your name I pray. Amen. Okay, so let me get back to the start of this thing. So any questions about number one? So here's my logic for number one. That's a circle, so it's got to be this one, because that's the only one that's got the equation of a circle. This is a natural log, which means it's got a vertical asymptote. The only one with a vertical asymptote is this one, so that has to be that one. So C is the first choice. This has a horizontal asymptote of 2. It's e to the x shifted up 2, which is this one. And this is, it's got a -4 is a horizontal asymptote. And this gets really large if x is really negative. So it's got to be that one. So the advice I've given the other sections. Oh, yeah, you're fine. You what? Oh. Yeah. Go on. You can catch the video. Yeah. Sorry about that. It is a weird thing, right? You take an online course and every test is like a self-destruct message, isn't it? Like if you open it, you have that much time left to do it, right? So like if you inadvertently open a test too early, what do you do? I think you should walk away and send your email to instructor. I'm sorry, I didn't mean to open the test. That was an accident. Please reset it for me. I haven't looked at it. And hope they give you mercy. Or do you have to do it right then because you might have a merciless instructor who would not give you a second try? So you don't know. I don't know. So take residential classes. You don't have to deal with this issue, right? Okay, so anyway, that's that one. Oops. What? Wait, where'd I go? Come on. All right, so the problem 2. Oh, before I got distracted, for problem 1, a good bit of advice for your formula sheet, a smart thing to do would be to actually have pictures of just, this is what y equals a to the x looks like, right? And this is what y equals log base a of x looks like, right? If you had those two, that could be very helpful in just making sure you don't go the wrong way, right? Another thing that should certainly be on the formula sheet is this, right? See, because this tells you that you have a circle which is centered at x naught, y naught with radius r, right? And so that's problem 2. So to do problem 2, we complete the square on x and y separately, right? So that I end up having to subtract 25 here and subtract 4 there, which then when I move all the numbers to the other side, I get 49, which shows me that I've got a center of 5 comma minus 2, and the radius is 7. Now some of you have minuses where you shouldn't, right? As a check, some of you have like -5, 2 here instead, right? Be careful about that. If you have the real center, when you plug it back into the formula, you should get 0, right? As a check. Problem 3, so I just noticed that 16 was 2 to the 4, and so that's how I handled it, yeah? Did you guys do it that way? number 3. So if you didn't see that 16 was 2 to the 4th power, the way to solve this one, another way you can do it, and I had somebody do this in the last section successfully, it was they just took the natural log of both sides. And what's that give you? That gives you 2x minus 3 times the natural log of 2 equals to the natural log of 16, right? Which gives you 2x log 2 equals log 16 plus 3 log 2, which then you can solve for x, right? There you go. So I get x is equal to the log of 16 plus 3 times the log of 2 divided by 2 log 2, yeah? Actually, this isn't quite how they did it. They used log base 2 of both sides, right? Maybe you did that. If I take the natural log, it gets me to this answer, which on the surface of things looks different, right? But if you actually plug this into your calculator, what you'll get is 3.5. So anyway, there's different ways to do this problem. Any questions? Right. Problem 4. I hope we can do better on this one. Generally speaking, like a lot of people got this wrong, which shouldn't need to happen anymore, I hope. So, and some of you got this right in the sense I didn't take points off, but you're still wrong because you wrote something here that was like, huh? So if I circled something and put a question mark next to it, that's my way of saying, this is wrong, I should take points off, but I'm not going to because, you know, I'm trying to be nice, but really it's wrong. You shouldn't say this. Something's crazy about what you said in some sense or another. Like some people put something about vertical line test here. I'm like, what? No. Like vertical line test just tells you if it's a function or not, right? These are both functions. That's fine. But the horizontal line test is what's interesting because failing the horizontal line test means the function's not one-to-one, which then tells us the inverse doesn't exist. Because a precondition for taking the inverse of a function is that the function's one-to-one. So good answers here would be something like the function's not one-to-one, so the inverse doesn't exist, right? Or just no, the function's not one-to-one, be a perfectly fine answer. And some of you gave that answer, all right? So I'm just saying. Over here, this does pass the horizontal line test, yeah? And to graph the inverse, like some of you have given me this. Like I saw this, a lot of it, like a quarter of the class gave me this answer for the graph, something like that, which is, you know, interesting, but not it. So to graph the inverse, all you got to do is take points on the graph that you're given and flip x and y. So like this 0.64 on the graph of the inverse becomes 4.6. This point minus 6.8 on the graph of the inverse becomes 8 minus 6. And then I just connect the dots. Now, another thing I didn't take points off for but was wrong, some of you have continued this line past that point in either direction. That shouldn't be the case, right? Here's one evidence that that's not the case. What's the domain of the function? Starts at minus 6, goes all the way over to 6, right? So the domain is minus 6 to 6. What's the range of the inverse function? Minus 6 to 6, right? So the domain of the function should match the range of the inverse function. You can check your graph with that. So it can't go on and on, right? These are line segments, not lines. Anyway, any questions about this? So those of you who got it wrong, I think you see, I can get that right next time, right? Yeah, this is something I can do if it's not just the day after Thanksgiving break, you monster. Let's see here. So, oh, so much sadness. Just weeping and gnashing of teeth on this problem. So, many people got this one wrong, which is not good because the reason that people got it wrong, a lot of people, is bad algebra. And what I mean by that is you couldn't really solve for x correctly. You've done something that is incorrect. let me address errors that I saw. So I probably shouldn't do this because writing wrong steps on the board, for those of you who are only like half hearing me, you might just write it down and think I'm telling you something true. I'm not. I'm telling you something that's not true. So this step right here is not correct. Right? What's the idea behind this step? The idea behind this step is that I can break the addition up, right? I can do x over x plus x over 3. There's just one problem. Algebra doesn't work like that, right? This is in fact not true. I mean, this equation, the equality over here is true, but this one is not equal. All right, so what is true, of course, if I had the x plus 3 upstairs and the x downstairs, that's fine. You can do that. Addition in the numerator breaks up just fine. No problem there. But this up here at the top is what one of my favorite instructors here will call bad algebra. Now, I don't think I wrote that on anybody's page, but I should have, you know. Now, so we're getting close to the final. A bit of advice I've given in a few of the other sections I'll give you guys too, because I think it's good advice, is that when you're about to do something mathematically sketchy and you have a bit of, like, a lot of you, when you make this kind of step, you're not making it from a place of confidence, right? You're making it from a place of, I'm going to do something. Maybe if I do something, that'll be it, right? If you have that feeling, check yourself. How do you check yourself? Well, put some numbers in, right? So if I try, like 5 over 5 plus 3, is it equal to, 1 plus 5 over 3? Does it actually work if I put x equal to 5? Well, 1 plus 5 over 3 is 8/3, yeah? But this is 5/8, right? So it doesn't work for one value, it won't work for all values, right? Like algebra steps are identities that are true for a multitude of variables for x. So if you can find a particular x where the thing you're thinking might be true fails, it probably is not, probably it's a wrong algebra step. I mean, the only, I say probably because if you made an arithmetic mistake and you're checking and accidentally made it work, then that's the sort of caveat there. But anyway, don't do that. Let us go back to the solution here. So this was that 4-step process, but we only went through 3 steps because I asked you to, here the problem asked for the inverse function of y, not x. So the first order of business is to write down, y equals to f of x, which is here. Then I solve for x. So I isolate the fraction with x, I cross multiply x plus 3 over here, I distribute through, I collect all my x's to one side, so I've got like this minus 2x, minus x gives me minus 3x, I've got my xy, I put the 3y on the other side, I factor x out, and then I solve for x. Then there you go, that's stuff in y, which is the inverse function of y, like I wrote up there. Now, the domain of the inverse function is the values for the variable that make sense for the formula, right? So everything makes sense here except for 3. So the domain for the inverse function is everything except for 3. But remember, the domain for the inverse function is the range for the function, so that tells us the range for the function is everything except for 3. So this is a little bit of a sneaky idea, but there it is. We don't actually have to graph the function to find the range if we found the formula for the inverse, because you can see domain just from looking at formula. Listen, let's do another one of these, because I think that there's a lot of weakness on this problem, and I think it's worth our time to work another example to review. Actually, I'll work 2. I'll work 2 examples of finding the inverse for you guys, because I think that's probably the most significant point of weakness on quiz 3 overall. If I had to guess one, pick one. So here's a different one. Suppose I had f of x equals to x plus 3 over, 2x minus 1. Let's calculate the formula for f inverse of y. So how do I do it? Step number 1, y equals to x plus 3 over 2x minus 1. Now I need to do what? Multiply by 2x minus 1, right? So 2x minus 1 times y is equal to x plus 3. Very good. Now, distribute, right? Yeah. So we get 2xy minus y equals to x plus 3. And that gives me 2xy minus x is equal to y plus 3. Yep, factor out the x. Solve for x. There you go. F inverse of y is equal to y plus 3 over 2y minus 1.
Question.
Sure.
Would you not just be able to just exchange the variables on the formula?
No.
X to y?
No, that would not be it.
It's the same answer.
Whoa. Whoa. That is a coincidence.
Could be an anomaly.
Really?
Yes.
Yeah.
This function's its own inverse.
Huh.
If we look at f of x, we get x plus 3 over 2x minus 1 plus 3 divided by 2 times x plus 3 over 2x minus 1 minus 1. So I'm composing the function with the function. And so then if I multiply the top and the bottom by 2x by minus 1, I get x plus 3 times 2x minus 1, 2 times x plus 3 minus 2x minus 1, which is 7x. Over 7, which is x again. Yeah. No, that's not a mistake. F of x composed with f of x is x again. That means f of x is its own inverse. This is an accident, guys. Like, I just made up this formula off the top of my head. This is like totally a coincidence.
Really?
This kind of thing only happens in here. If you asked me to find a function that's its own inverse, the only thing I'd be able to tell you in a typical day would be this. The only function I know of, like right off the top of my head, it's its own inverse is the reciprocal function. That's its own inverse, because if you reciprocal the reciprocal, you get back where you started again. That's an inverse function, which is the function itself. This is really weird. That's not usually the case. So sorry that happened, but I'm not sorry. Sorry, not sorry. Can we go on and do a different example, which is less weird?
Yes.
Sorry. I really should have asked you to compose a formula with the formula in the test quiz, but that ship has sailed at this point.
There we go.
Man,
Is this the first time you've ever seen this?
it doesn't usually happen like that. I mean, they're usually, these functions, they usually work out, oops, no. They usually work out so that they're like similar looking, but they're not the same.
Taking a picture or something?
Yeah, I gotta remember this one. All right. Here, let's work one that's different. Oh, that's weird. I'm sorry, that's still just, go.
Boggling your mind?
Yes, my mind is boggled. Let's see here, f of x equal to, 7 plus log base of 3 of 2x plus 1. Find the inverse function for this one. Can you do it? Find the inverse function. Now, if we have the same formula trading x for y again, I'm going to, that would be That would be amazing.
That'd be hilarious.
If we get the same formula for this one with like just trading x for y, everyone in this room gets 20 bonus points.
Wow.
Let's see what happens.
Is this like another example of problem 5?
Yeah, it's another problem 5 example.
Okay.
But this one is a little bit different, see, because it's not a rational function, right? Okay, so let's do it. Y equals to 7. That was an empty promise. It's not going to happen again. Log 3 of 2x plus 1. Now I solve for x, right? How do you solve for x here? Isolate the logarithm, right? So I've got log 3, 2x plus 1 is y minus 7, yeah? How do I get that x on its lonesome? How do I get rid of the log? What's the natural enemy of the log base 3? It is the base 3 exponential function, right? So I take both sides. Yeah, like that. And so these are natural, they cancel out. We get 2x plus 1 is equal to 3 to the y minus 7. And so then I solve for x. So there you go. F inverse of y is 1/2 times 3 to the y minus 7 minus 1. It is quite obviously not the same. But so this is the thing, is the inverse of an exponential is a log, and the inverse of a log is an exponential. And that's still true if your exponential and log are like shifted around and messed with a little bit. Right? This is not straight up a logarithm, is it? I mean, this is a logarithm that's been like compressed by a factor of 2, shifted, and then vertically translated as well, right? It's got a vertical and a horizontal translation as well as a compression or a stretching as well. I mean, like there's a lot going on in the original function. It's not just a plain logarithm, just like its inverse is not just a plain exponential, right? It's an exponential that's been, you know, compressed by a factor of a half, shifted 7 units to the right, and then like shift down 1, however you want to look at it, you know. But like as a general point of order, if somebody asks you to find the inverse function for something that's like a log, you kind of should expect something like an exponential for your inverse function. If you were to find the inverse function of something like an exponential, you'll get a log. The weird thing is, the functions we were doing examples with at the start of this material, they're rational functions. Things like, you know, like this, x over x plus 3 plus 2. And it turns out that those kind of rational functions, again, have rational functions as their inverse, which is why we could have happen what just happened before, to actually find the function as its own inverse. Very weird.
Will we find one of those on the test?
I would have to make up another one other than the one I just did. That would take me time.
Or you can just use the same one.
I could just use the same one. You guys are so kind. Let's see here. So all right, I'm going to go on. Whoa. Huh. Okay. Yeah, exciting. The key here, and so if you got this one wrong, I'm sorry. I know it must feel bad. Because like this one you could have gotten, right? We could all get this problem. And the key to getting it is to know this. Natural log of e to the x is x, right? If you know that, that's the keys to the kingdom here, so to speak, right? Because the same thing with x equals to 8 is what? And what's the natural log of e? E to the 1, right? Which is 1. And so that is what you need to know to like see past the ugly looking given problem and realize that that's really just x minus 6 equals to 8, which of course has 14 as a solution, right? The next one, we can use the one-to-one property to log base 3 to get this, then isolate x and solve to get 3. So problem 8 and 9, there's like a lot of people have, you know, like partial progress here. There's hope, but you guys are just not quite solid yet on everything. Now this 2 was tricky, right? You're like, curses, what have you done to me? What's this 2? I can't make that into a log, but you can, right? You can make a 2 into a log. You need to think a little bit differently about that. And the key identity there is, well, remember, x is equal to log base a of a to the x, right? So I can do 2 is equal to log base 10 of 10 to the 2, which of course is log of 100. So that's what went on there. If I had added 3 instead of 2 in this problem, what would I have put? I would have put plus log of 1,000, right? And so forth. So hopefully now that you've seen this trick, you can make use of it when I ask a similar question on the test, right? I'm thinking about converting these questions to like multiple choice. This particular corner of the test, I think it might be good in a multiple choice format. So I'm debating whether or not to do that. The other thing people missed here, a fair number of people's, is the 3. Like this 3 just disappeared somehow, and it didn't. I mean, the 3 over here, it kind of just went away, and it somehow didn't come back down here like it should. So there's, I don't know, 30% of the class made that error, something like that. I would say another 30%, maybe 50% of the class, they decided that this square root was optional. So they just kind of like, it just kind of poof, it just disappeared. And just didn't do it at all.
What did you think about it?
So I don't know, if you didn't do it at all, does my previous comment apply in that case? I don't, maybe? You were thinking, so I can't discern thoughts not written on paper, unfortunately, but anyway, so I pull the half out because that's overall to the half power, right? So that brings a half out front. And then we use properties of logs. So I've got log of the sum of the thing products in the numerator minus the 1 in the denominator. And then I pull the 3 down by property and the 5 down by the property of the log, which gives me that. So anyway, a lot of people got this right, but maybe half and half. I don't know exactly, but everyone can get these problems right on the test, right?
Oh, yeah.
Yes.
Absolutely. On the 9, is it okay if we left it in the 1/2 out front?
Oh yeah, 1/2 could be stay out front. That'd be fine. Yeah, yeah. I hope I didn't take off points.
No, you didn't.
Okay, good. Problem 10. So some of you solved this with log base 2, right? So let me talk about that just a second here. Actually, before I even talk about that while I'm erasing, some of you solved this by guessing. I don't know if anybody in here did that. I had some people in some sections go like, just take their calculator and plug x into it, and just like, until it got really close to 5, and then they're like, so the answer is 2.32. And I don't dismiss that as an answer. However, if you do that, it does not suffice to just write x equals 2.32. You need to write x equals 2.32 and a sentence off to the side which says, hey, I plugged numbers into my calculator until I got sufficiently close, therefore I know this is the answer. I do need a sentence to the side explaining to me how you did it. Otherwise, if it's just an answer, I take points off because I do give partial credit, and as such, I have to take off work points when there's no work, generally speaking. But of course, we do not need to use brute force numerical methods to solve this problem. Like, that is definitely not the right way to do this. And it's very time consuming. Well, maybe not that time consuming, but so another way to do this would be, sort of like a mathematically easiest way would be take log base 2 of both sides, right? What happens then? Well, this is exactly x. And so the answer is log base 2 of 5, right? End of story. There you go. That's the answer. And listen, if this problem didn't have that pesky and write the approximate answer to 2 decimal places, then this could be the answer to problem 10, and that would be it, right? But because it has the numerical part, we need a method to calculate. Now, if you can calculate this on your calculator, more power to you, great, right? But what if you can't? Well, we can use the change of base formula. This is natural log of 5 divided by natural log of 2. And so you certainly should have natural log on your calculator, right? If you don't have natural log on your calculator, you need to get a different calculator for the test, yeah? All right, so.
What if I do natural log instead of just a log?
Like common log?
Yeah.
Well, yeah, if you did common log here, it would be uglier because you'd have common log of 2 to the x, common log of 5, which would give you x common log of 2, which could give you x is common log of 5 divided by the common log of 2. I mean, you could do it that way too, and that would still work out, the 2.32. You could do that. So, certainly, because there is the common log on the calculator too. That is true. All right, so let's talk about number 11. I hope I'm here for the test Friday. There exists the chance that I'm coming down with the flu.
Oh,
So,
what do you mean there exists a chance?
well, I could be more optimistic. Maybe it's just COVID. I don't know. But sorry. No, we had a child that was sick with a high fever for like 3 days, and they're better. But then the next child is sick with a high fever, and he's 2 days into it now, a day and a half. So the question is, where does this end? Does it end with me? Does it end with my wife? What about the other 3 children? I don't know. We'll see. Yep.
Was one of the kids that were sick the one helping with our quizzes?
No.
Okay.
No, he was the not sick one. Yeah. Yes, I foolishly asked my son to add up so like I grade it, and I always write these numbers in the bottom of the page, right? And because I was up very late, watching the sick child, and anyway, I was grading to the last minute this morning. I thought, oh, I will ask my 14-year-old to add up the points in the corner. This will go well. It seemed reasonable. And then he decided to put comments about certain scores, like at the top, and so I have whited those comments out. Yeah, you're going to try to figure out what it says now, aren't you?
They
But-
possibly could say meh.
They could have said meh. Yeah, he said meh. I'm like, no. He asked me not to do, he asked me, should I do this? I'm like, no, you should not do this. And he still did it. I was going to pay him, but now I think I'm going to charge him. So,
What kind of tour?
what kind, like electronic time, like no electronic,
okay.
something like that. That's where it hurts, right? No Fortnite for you tomorrow, or whatever. Actually, they've kind of, they don't do Fortnite so much now. They're playing some other game. It doesn't matter. But they play a lot of Minecraft with their cousins too. The trouble though is their cousin Peter is like, if you're playing Minecraft with Peter and you don't pay attention, like go to the bathroom or something, you come back, Peter will have burnt your house down and stolen all your stuff. He may be your cousin, but he will loot and pillage you when you give him the chance. Only in survival mode, because in creative it's not interesting. So, yeah.
You're a gamer?
I am not a gamer, but I am around it. I am not. I should become a gamer.
Yes. Who cares about math?
Who cares about math?
You want to care
Math-
about math and game? Play cool math.
Math is the ultimate game, though. See, if you win a certain level in math, and you're the first person to win it, like it lasts for centuries.
Play cool math. You can play Geometry Dash. Come on.
Geometry. Geometry Dash. All right, I feel like what's going to happen here is we're going to run out of time if I'm not careful. Okay, so here, some of you got the answer of 4. How did that happen? I can tell you how it happened.
I'll show you my work.
I can tell you how the 4 happened. Here's how it happened. Getting the answer 4 comes from looking at this and going, I don't like log base 4. I'm not comfortable with that. I'm just going to ignore it. And so if we just delete log 4 and we write x plus x minus 6 equals to 2, that gives us 2x equals to 8, which gives us x equals to 4. Which is incorrect. Because, in fact, much like the square root earlier in the test, you cannot just ignore the log base 4. Like, this is part of the problem. You have to deal with it. So, I don't know. People did different wrong things. But listen, so what we have to do is use the property of logs to do log of the sum of the logs, the log of the product, like that. And then I take both sides, raise it to the 4, 4 to both sides. That gives me this is equal to 16, which then I rearrange, I factor, I get 8 and minus 2 as solutions. But of course, only the 8 survives because minus 2 doesn't work, because if you plug minus 2 back up in, you get log of a negative number, which is not allowed, because we don't look at principal branches of complex logs in here. Anyway, so, yep. So that's extraneous. Rule that one out. 8 is the answer here. There are people who got this right. Hey, does this problem look familiar? Because it should. I did this example in class. Yeah. In fact, that's true of a lot of problems on this quiz, isn't it? Problem 12. Now, listen, I am sympathetic to everybody who got this wrong, because this is something we did like 2 examples of maybe in here, and then we walked away from it. I did not belabor this. And there's only like 2 problems in your homework on this. Maybe not that, maybe just one or two. So it's easy to have missed this idea. If you have missed it before, please pay attention to it now, because there's a decent chance this is on test 3, something like this, where you have to make a quadratic substitution in order to solve the problem. So, as a general point of order, if you've got like the same base, but the argument is like doubled on one versus the other, maybe it's one of these problems, maybe. So what happens here? We get this quadratic, we factor it. That gives us either 4 or minus 1, but the thing is, e to the x equals to minus 1, that doesn't work, right? E to the x is positive, there's no solution to this. This has the solution of log 4, and so there you go. Problem 13. Listen, lots of people got problem 13 right. This was definitely a bright point on the test. I think most people got 13 right. Now, if you got 13 wrong, more of these?
Yeah, I can actually do these.
Yeah, take out the logs.
Take out the logs and just focus on this?
Yeah. Let's only do questions like number 13. You can even put 3 on there. Yeah. Like the ones that, X, Y, and
I like it when people ask for custom tests.
You what?
I like it when people ask for custom tests.
Does that mean you're not going to put them on there?
I want me to make you a special test that just has systems of linear equations?
Yeah. Yeah, can that be the final? Yes.
Huh.
I hope there's like at least a page of these. That's a lot. But I can do so.
What if instead of it was x and y's, what if it was like 2 times the natural log of x plus 3 times the natural log of y? No?
Fractions where it's like 2x over like 3 and then plus 3.
No logs.
I'll take it.
You have to have logs.
Those are for lumberjacks.
Okay, so let me wrap it up here. So if you got this problem wrong, it's easy to get it right. What you got to do is use substitution. Solve one of the equations for y, plug it into the other one. You'll get one equation just for x, which you can solve. That's all I did. See, I solved for y. I plugged it into the other one. That gave me 11x equals to 1, 11 rather, which gives me x equals to 1. Plug in the other one, I get 2. So problem 14. What's problem 14? Where's that coming from? These were like the last few problems in homework 12 were like this, yeah? Remember those symbolic ones? Maybe you don't, I don't know. But so I want to solve for a, so my first move is to get rid of the exponential. I take the natural log of both sides, which is an inverse function to the exponential. It gives me log of AB equals natural log of C. Now by properties of the log, I get, and by the way, why does the e and the log not cancel to start with? Why isn't e to the log just AB? Why isn't it the case? Why isn't it not the case that e to the log of stuff, why is this not equal to stuff? Why don't they just cancel? I thought exponential and log were inverse functions. What's the deal? Because it's what? Because it's not the natural log, right? Because this is base 10. So it is the case that 10 to the log of stuff equal stuff. Sure, but that's not 10, that's E, right? So that's not how it simplifies. There's a few people who did it, just a small subset of people who did that. Then I use properties of logs to get log of A plus log of B. I solve for A by taking, solve for log A, then take 10 to both sides, get this. Properties of the, properties of exponentials, give me that. Then this simplifies to B to the minus 1, which is division by B. There it is. There are a few people who got this answer. And then finally, problem 15. Problem 15, everybody should have had C equals to 3. This was easy to get, right? Because if I tell you 0, 3 is in the graph of a polynomial, that tells you that the y-intercept is 3, right? Which means that the constant term in the polynomial is 3, right? So yeah, C is 3. And the other 2 points, when I plug them in, they give me A plus B plus C is 6, and A minus B plus C. Notice the minus, because minus 1 squared is 1, but B times minus 1 is minus B. But we know C is 3, so we plug it in, we clean it up, we get A plus B is 3, and A minus B is 1. Add the equations, we get 2A is 4, which gives us A is 2. Plug it into the other one, we get B is 1. And so there's the answer. Now, I think about 10% of the class overall got this, maybe 5. I don't know. It's not everybody got this, but everybody can get this, right? This problem's actually not that bad. You just need to, some of you are still not clear on how to put the points into the formula. So if you're that person, focus on what's the logic that goes from here to there, yeah? Anyway, see you guys Friday. Oh, final exam. When is it?
Friday at 3:30 to 5.
I had just gotten out the final exam schedule. The other. So what time does this class meet?
3:30 to 5. It's that on the box.
This one right here, right?
Yeah.
So on when? December 9th, 3:30 to 5:30, right? So if you are using ODAS, that might be a problem for you in terms of extra time, because I think they close at 5 or something. So if you need extra time on the final, and you're a person that's been approved for and stuff like that, just talk to me and we can add time after class. Like I can just let you go after 5:30 here, if that works for you. Anyway, if you're a person who needs extra time, we should talk, okay? So.
Will it be like the